Hello, beautiful people, and welcome. In today's video, we will be discussing a very special right triangle. Before we jump into that, we are going to talk about square roots. Now, it's not a lesson. This is just reminding you how to multiply square roots and how to divide square roots. Let's jump in with our first example. For our example number 1, let's go ahead and do the square root of 3 times the square root of 4. Now you have two options when you're dealing with square roots in multiplication. You can choose to simplify first, if possible, and then you can multiply. So if we are choosing to simplify first, we have 3 times the square root of 4. Square root of 4 we know is 2. 2 is now outside of the radical. There is no house around it. It's not inside the square root anymore. So we have 2 is outside, 3 is still inside. And so when you're writing the multiplication, you just write them kind of next to each other. Now, what if we choose to multiply first? So if we're choosing to multiply first, which is fine, there's nothing wrong with that. We got 3 and we got 4. Well, that's just the square root of 12. Here's the issue with multiplying first when you should have potentially simplified first, because you're going to still need to break up the square root of 12 to simplify. So it's kind of like doing and then undoing. You just have to be careful. If you can simplify first, do that, because we would then simplify by writing this out as 3 times 4, which we just had, which is 3 times 4, square root of 3, square root of 4, which we just had. And we know the square root of 4 is 2. And it's kind of like you're going a little bit in a circle on this. That doesn't always happen in this example. It did. Sometimes when you multiply numbers, you can get other factors of it, like originally it couldn't simplify and then it can simplify. So just take a look and see which one is better for which example. Let's go ahead and do question number 2. Oop, not number 1, question number 2. So we have square root of 10 times the square root of 8. Again, you have two options here. You can choose to simplify first, or you can choose to multiply things out. That is up to you. I am going to choose to, let's simplify first since it worked really well for us last time. We have square root of 10. Square root of 10 is just 5 times 2. And then we have square root of 8, which is 4 times 2. Immediately, I'm doing a mini happy dance because I see a 4. 4 is just 2. So that means, what do we have? We have 2 on the outside. We have 5 times 2 times 2 on the inside. Now be careful when you're doing this, because yes, you can just multiply this out and get the square root of 20. But you are not done yet, because I can continue rewriting the square root of 20 as the square root of 4 times the square root of 5, which we already know square root of 4 is another 2. So that means we got 2 on the outside. We got another 2 on the outside. And I'm just circling this to know which one is which. And then we have leftover of 5. So that means outside of the house, that is 4 root 5 as our answer. Now you could have chosen to multiply and get this as 80 and then simplify 80 with different factors. That is okay. Now when you are dividing, again, check if you can simplify first. If you have a radical in the denominator that cannot be simplified, that's where things get a little bit tricky. So let's simplify. I got the square root of 25, which is 5. I got the square root of 4, which is 2. So what we have is 5 over 2 times 2. Let me highlight which one is which. So you got this 2 is this 2. So we got 5/4 as our answer. Square root of 4 is 2. Square root of 5 is 5. So we get 2 over 3 times 5, which is 2 over 15. This is what I was referring to, is when you cannot simplify, like the square root of 2, in the denominator. Now, in the numerator, doesn't matter. You can have a radical in the numerator. In the denominator, that's where things get tricky. So what you're going to do is you're going to rationalize the denominator. You're going to take that radical and only that radical. You're going to multiply top and bottom. You're going to multiply on the inside. So we got 3 times 2 is 6. We got 2 times 2 is 4. And then you can continue to simplify. For example, square root of 4 is 2. So we got square root of 6 over 2 as our answer. No, you cannot simplify the square root of 6, divide it by 2, and make it 3. Can't happen. You have a house. 6 is inside of the house. It's inside of the radical. 2 is not inside the house. You don't want 2 to go inside the house, so we have to keep them separate. Let's do it again. We see a square root of 5. That cannot be simplified, so I'm going to rationalize the denominator. So we got square root of, ooh, wait a minute. I can simplify square root of 4. That's just 2. So I get 2 root 5 divided by square root of 5 times 5 is 25. So we get square root of 25 is just 5. 2 root 5 divided by 5. Again, square root of 5 is inside a house. 5 in the denominator is not inside a house. So we cannot simplify these two. Let's do 2 more quick examples, and then we actually move on to our lesson of the day. Now, when you have something like this in the denominator, where you have example 5 not inside a radical, and then you have 3 inside of the square root, only take the one that's inside the square root. There's nothing wrong with 5. It's not inside the house. It's not inside the radical. Nothing wrong with it. So you're going to take that square root of 3 and only use square root of 3. So we still have 5, square root of 9. Square root of 9 is 3. Square root of 9 is 3. So what do we have? We have 3 over 5 times 3. 3 over 15. Now this can simplify to 1/5. Now be careful on the next one. There is a binomial in the numerator. That means you're going to have to distribute. But just like the previous examples, just take the radical in the denominator, take the square root. Everything else is fine. And I'm going to put parentheses around here so I don't accidentally forget to distribute. And I'm going to do the denominator first. We got 2 times square root of 3 times square root of 3. That's 9. Here we need to distribute. So we got 2 times the square root of 3 minus 5 times the square root of 9. Simplify when you can. This is just times 3. This is just times 3. So we have 2 square root of 3 minus 15 divided by 6. No, you cannot simplify 2 and 6. Now the reason being is because of this minus. Because now you have a binomial in the numerator, either you simplify everything or you don't touch it. So we're going to not touch it. Just a quick example or two there. All right, let's actually go and talk about our special right triangle. The first special right triangle we're talking about, and yes, there will be 2 of them, is a 45, 45, 90 degree triangle. You will see this a lot in our upcoming units. In a 45 degree, 90 triangle, the hypotenuse is the square root of 2 times as long as each leg. Now, 45 and 45, 90 means that we have a 90 degree, we have a 45 degree, and we have a 45 degree. That means that this triangle, this special triangle, is a 90 degree right triangle, but also isosceles. That means that we have these two which are congruent. So if we have one side x, then the other side also has to be x because it's isosceles. Isosceles means that we have two legs that are congruent. Now, if we continue using the Pythagorean theorem, a squared plus b squared equals c squared, x squared plus x squared equals c squared, what you end up having is this pattern where you have x times the square root of 2 as your hypotenuse. And this will always, always, always be true for your 45, 45, 90 triangle. So how does it work and how do we do this? So let's say we are solving for the hypotenuse. First thing I want you to do is label with the pattern. So what is our pattern? Now there is an X already here. If you want to change it to a different letter, that's fine. I think actually I am going to do that. I'm going to remove it, make it like a, I don't know, what's a random letter? R or something? Because I don't want to get that confused. And I'll change, oop, I see that? Older whiteout. Anyways, let's make this, oh, I don't know. I think I said R. That part doesn't matter. Okay, so let's label. We have an X, we have an X, we have an X root 2. When you label your pattern, you're going to create these little mini equations. And you're going to solve for X or the unknown. So what do I mean by mini equation? Here is a mini equation. I'm going to throw in a little equals. So that means our mini equation is x equals 2. X equals 2. R is equal to x root 2. Okay, we have our mini equations. Well, if x is equal to 2, we can take that 2, replace it, and have 2 root 2 as our r value, which is our hippo across the street from the 90-degree angle. And that's your answer. As long as you have the pattern memorized, you're going to be okay. Now, yes, there will be a little bit more challenging questions you'll see, but that's pretty much the gist of it. Label your pattern, create mini equations, solve for your x value. Okay, let's do it again. We have x root 2. Again, that's always across the street from your 90. Mini equations, we have x equals root 5, x equals root 5, r is equal to x root 2. We have our mini equations. So that means that we're going to replace x with the square root of 5 times the square root of 2. And we're going to simplify because now we are comfortable with multiplying. 5 times 2 is 10. Cannot simplify the square root of 10. So that is your r value. Let's go ahead and do a few more examples. Again, we're still solving for the hypotenuse. Hippo is across the street from your 90 degrees. Again, this is x, so if you want to change that to r or any letter, let's call this a this time, you can do that there. Label your pattern. Trying to get a different color here. Label your pattern. So we got x root 2. Set up your mini equations. Plug in or solve for x. So we have x is root 10, so we don't really need to solve for x. We're just going to replace, simplify, multiply, and then simplify. 10 times 2 is 20. And 20 can be split up. So I can do square root of 4 times square root of 5, Square root of 4 is 2. So that means my hypotenuse is 2 root 5. Now here's super duper important that yes, you must simplify. No, you cannot give me a decimal as an answer. If you give me a decimal as an answer, it will be marked wrong. All right, let's go again. Okay, be careful. Make sure you set up what your hypotenuse is. Again, I have x here, so I'm going to remove that x and give it a different letter. Let's call it C. Why not, right? It's a hypotenuse. Set up your mini equations. So we have x is equal to square root of 3. X is equal to square root of 3. C is equal to x times the square root of 2. Nothing to solve here because we already know what x is. X is the square root of 3. So square root of 3 times square root of 2. 3 times 2 is 6. 6 cannot be simplified. So that is our answer. Again, as long as you have your pattern memorized, these are going to be okay. So that was solving for the hypotenuse. Now let's go ahead and solve for the leg. Okay. The steps are the same. Step number 1, set up the equation. Step number 2, solve for the leg. So in this case, they already gave us x's here. So we're going to, what did I say? Let's label the pattern. Create mini equations. Solve for x. Okay, let's go ahead and do this one. Hopefully I won't run out of space. So what is our equation? Now it's already giving me x, so I'm just going to keep it. So we have x, x, and here we have x root 2. So although I did put an x here and an x here, we kind of don't need it. This is the mini equation that I'm referring to because that's the only one with actual decent information for us to work with. The other ones, that doesn't really help us. So our mini equation is 10 root 2 is equal to x root 2. Now there's different ways of doing this, but I'm going to show you the way that's going to always work and help you in tomorrow's lesson, which is another special right triangle. You're going to take the radical that is attached to x, and you're going to divide both sides by that radical. And again, I know you can just look and see what x is. I get that. But I want to prepare you for our next lesson where you will need to divide. So you're going to divide. These go away. These go away. X is equal to 10. Okay, let's try it again. Set up your equation. So x root 2 is equal to 4 root 2. Get into the habit of dividing by whatever's attached to x. So we get those go away. X is equal to 2 divided by 2 inside the house. Inside the house. That means they can be go away. And this is 4. Let's go again one last time. So we have, again, which one do we need? We need this one. Now, beautiful people, I want to point something out. Let's go back to this one for the leg length. Because I'm telling you that these are congruent, we know that this has to be 45 degrees. And this is very important because starting tomorrow, I'm going to throw in different patterns for a different special right triangle. And that's going to change up a lot of what we're doing. So make sure you know that these are only specific to 45, 45, 90 triangle patterns. So we have x root 2. So set up your mini equation. Divide by what's in front of x, or what's next to x. x is equal to 5. Right? Let's do one more. So if you're given something like this, more than one triangle, be very careful about the angles because angles will tell you what is where. So let's take a look at this triangle. Two pieces of information, technically three, that they are giving you. They are telling you that this is an isosceles triangle. So that means that we have 45, 45 degrees. Super duper important. That means that we have x here and x here. And that means that this is our hypotenuse. So I'm writing out our pattern. And I'm going to highlight it that this hypotenuse is 8 root 2. So I'm going to set up my mini equation. 8 root 2 is equal to x root 2. Again, we already see that x is 8, but get into the habit of dividing by whatever in front of x. Or next to x. I guess it's not in front of it, it's next to it. And that is 8. So we know that this is 8, we know that this is 8, we know that this is 8, and they are telling us that this is congruent, equal in measure, and that is 8 as well. All right, beautiful people. If you're in my class, you have your homework assignment. Go ahead and get started on that, and I will see you in the next video.